Hello, as many of you may know, my name is Marco Slanio, and I'm gonna do a mechanics problem here for you guys to show you how it's done, basically. This is a conservation of energy problem using incorporating rotational energy. What we have is a can at the top of an incline that's 25 degrees from the horizontal and is 3 meters long. The can has a mass of 215 grams, a height of 10.8 centimeters, a diameter of 6.38 centimeters. Now the only thing we know about this can's motion is it takes 1.5 seconds to get to the bottom. Since this is a conservation of energy problem, we know that mgh, which is potential energy, is equal to half mv squared plus half I omega squared. Translational kinetic energy plus rotational kinetic energy. Now the problem is that in this equation, we don't have v or I or omega, but it's okay we don't have I because that's what we're looking for. To get v, we need to remember the very basics of what velocity is. Okay? Velocity is distance over time. And we have a distance, 3 meters, and we have a time, 1.5 seconds. So it's 3 over 1.5, which is 2 seconds. But this is only average velocity. So this would be the velocity if there were no friction, 2 meters per second. So this would be the velocity if there were no friction. That's how fast it would have to go the whole time to get down there. But it's accelerating, so that's not what's actually happening. We also know that average velocity is equal to Vf plus Vi over 2. Now since it starts at rest, Vi is 0. So we just get Vf over 2. The V we're interested in is Vf. So this tells us that Vf is equal to 2 V average, which is 2 times 2, which is 4 meters per second. So that's the V we're going to use in here. We also know something that relates omega to V. We know that omega is V over R, with R being the radius of the cylinder, the radius around which it rotates. So we can rearrange this equation to get I. First of all, we're going to get rid of these 1/2s and put 2 up here. Now we're going to substitute for omega. So 2 mgh is going to be mv squared plus I v squared over r squared. I substituted and squared it. So now I'm going to get rid of this r so I don't have any more fractions. Put an r squared here and r squared over here. So since we're looking for I, next thing I'm going to do is I'm going to move mv squared r squared to the other side so we have iv squared all by itself. So I have 2 r squared minus mv squared r squared. That's going to equal iv squared. Next, we're going to divide by v squared across the board. So this v squared goes away, this v squared goes away, and we have this over v squared right there. Now we have all the dimensions and we can just substitute to find I. The only thing we need to do is convert this from a diameter in centimeters to a radius in meters, and this from grams to kilograms. Grams to kilograms is simple. Just move the decimal point 3 places over to the right. So now 0.215 kilograms. This to centimeters, we have to slice it in half. So we know d over 2 is r. So that's going to be 6.38 over 2, which is 3.19 centimeters. Move decimal place over twice, 0.0319 meters. So now we can do the substitution. We know 2 times the mass, 0.215, times g, which we all know to be 9.8, times the height of the ramp, which we haven't found, but from trigonometry we know that this distance here is going to be 3 times the sine of the 25 degrees. So it's going to be 3 sine of 25 degrees times the r that we found squared. So 0.0319 squared over 4 squared, the final velocity, minus 0.215 times the radius, 0.0319 squared. That's going to give us I. So when you do all this and all the crazy stuff over here, you get that I equals 1.21 times 10 to the negative 4 kilograms meter squared.
I can ride my bike with no handlebars, no handlebars, no handlebars. I can ride my bike with no handlebars.